Alright, so in this video we're going to be looking at changing the amplitude. So this is our first one for our trig graph transformations. We're mostly going to be looking at the sine wave and the cosine wave in this video and subsequent ones. However, you can still apply these ideas to the tangent function as well. So let's take a look at it. So here I've got my sine wave and my cosine wave. Now let's just quickly review over it. If I was to think about my sine where it is 90, I know at that 90 degrees, that's my highest point. So my y value is 1 there. But what if I had, let's say, 3 sine 90? So I imagine it as 3 sine x. Well, that would be 3 times our sine 90, which is 1, which is just going to end up with 3. And in a similar way, if I was dealing with sine 270, looking at my sine graph, I can see that's going to be minus 1. So if I had y equals 3 sine 270, that's going to be 3 times the minus 1. So that's going to give me negative 3. So essentially what's happened is that I've taken my maximum and minimum and I have multiplied them by the number that's at the front. And as a result, my amplitude has gone from 1 to 3 in these cases. And the exact same idea happens with our cosine wave. So if I dealt with y equals cos 360, that is our value for 1 there. So 360, that goes up to 1. So in the same idea, if I had y equals 3 cos 360, that would be 3 times the 1, which is going to be 3. So the exact same idea occurs here. So let's take a look at some questions which are you're more likely to see. So for these ones, we've got sketch the graph y equals 10 sine x. Now, the first thing I would always do is sketch the basic sine x graph. So my basic sine x graph, remember, it's the s on its side, my maximum's 1, my minimum is minus 1. I pass through at 180 and 360. So that's my basic one. So my y equals 10 sine x. The shape's going to be the exact same. I'm still going to pass through 180 and the 360. But remember, now I basically changed my amplitude from 1 to 10. So that's going to be 10 at the top and minus 10 at the bottom. So same idea for this next one. Sketching my cos wave, I think of cos I'm happy. So I've got the 1, the minus 1, and it passes through at 90 and 270. So that's my y equals cos x. So now sketching my y equals 7 cos x. The shape's the exact same, and I've got 90, 270. Except my amplitude has now gone from 1 to 7. So that's going to be 7 at the top and minus 7 at the bottom. And you can see here how rough these sketches are. I'm just getting the general shape down. I'm just getting the key points written on the graph. It doesn't have to be a perfect bit of art. So let's take a look at these two here. So again, I'm just going to sketch out my basic sine graph. That was really wonky, actually. So that's my basic one. Now, I wanted to find out what y minus sine x is going to be. So think of it this way. When I had y equals x squared, I have my axes and then I have my parabola like so. And y equals minus x squared, I had my axes and then my parabola flipped underneath the x-axis It's in the exact same shape, but it's now underneath the graph. We want to apply the same idea here with our sine wave. So we want to take the shape here and flip it around that x-axis so it's the other way around. So I draw my axes and I flip it so it's the other way around. So normally I go up from 0, but this time I'm going to go down, then up, then back down again. But I still pass through the 180, still pass through the 360, and because I haven't changed the number that's in front, it's still going to be 1 and minus 1. So let's take a look at this one here. I've got y equals negative 5 cos x. So I'm going to first sketch my normal cos graph. Again, for our Williams, because I'm happy. So 1, minus 1, 90, and 270. So I could do this in little chunks. Right, first draw out the minus cos x and then minus 5 cos x. But I'm actually just going to do this in one step together. So again, I pay attention to that negative and I go, right, it's going to be the other way around. So normally I start at 1. So this time I'm going to start at the minus 1. And this time I'm going to hit the curve at the top and then come back down. Ooh, not start at minus 1. I meant start in the negatives, sorry. But this time, because it's the 5 there, that means my amplitude is now 5. So the top is 5 and the bottom is minus 5. Okay. So another way we can be asked these questions is with ones like these, where we've been told the following graphs show the function y equals a sine x plus b and y equals a cos x plus b in the interval 0 is less than or equal to x, which is less than or equal to 360 degrees. State the value of a. So we're just going to ignore these plus b parts. I'm going to refer to them in my next video. My main focus is I want to identify sort of what my amplitude is and if my graph has been flipped upside down. So looking at question 1, the distance from 0 to the 15, that's going to be 15 there. And again, 0 to that minus 15. Oh, got a few minuses there. 0 to that minus 15 is also 15. So that means my amplitude there, the A is 1. Not 1, 15. Even wrote 15 there. Same idea for question 2. The height from the middle to the top there is 9. And from the middle to the bottom is also 9. So that means A is going to equal 9. Now question 3, this is where it can be a little bit weird, because if I just use the X line, that distance there is 6, but the distance to my bottom is just 2. So that's not going to work. Now with my cos wave, the easiest way to sort of look at it is the entire distance. So that entire distance there from 6 to minus 2 is going to be 8. So if I half it, that's going to be my 2 middle to the top and middle to the bottom. So that's going to be a distance of 4. So A equals 4. Same down here with question 4. The entire distance from my highest point to my lowest, the entire distance there is 4. So halving that, that means A equals 2. Question 5, I can see my sine wave has been flipped upside down. So it's going to be a negative. And then here I'm back to having those two distances of 3 and 3. So A is going to equal minus 3. And the last one, question 6. Again, I can see my cos wave has flipped upside down into a frown. So it's going to be a minus. So the entire distance from top to bottom from 7 to minus 3 is 10. So then halving that is going to give me 5. So that is our first trig transformation where we change the amplitude. And we're going to go into a bit of these sort of graphs here where we do deal with this plus b and how it works in the next video. Let me know if you have any questions, and good luck with the work.